Okay, hello everyone. Today our topic is about separating substances. Page 100 and 101. First of all, I want to introduce a new word called particles. Particles are little tiny things, we could say, that make matter. Okay. For example, we have the three states of matter that we're going to talk about today. The first one is solid, the second one is liquid, and the third one is gas. Let's talk about the particles of a solid. 1. The particles of a solid are very close to each other and they vibrate in their spot. These are the particles that I am talking about, little tiny atoms that form the solid. 2. Solids have a fixed shape. What does it mean having a fixed shape? The word fixed means that the shape of it does not change according to the place that you put it in or according to what container or table or bag you put it in. So if I have this piece of paper, for example, or this pen, and I place it on the table, it's still a solid. If I put it in a cup, it's still a solid. That's what fixed shape means. 3, they also have a fixed volume. And as we talked about before, volume is the space that the matter takes up. So, this paper is taking all of this space on the table. So, the space that it's taking on the table is its volume. Now let's talk about liquids. Liquids particles are a little bit more further than the particles of a solid. Also, they do not have a fixed shape. That means if I pour liquid on the table or if I pour liquid on the cup, the shape will change according to its container. So it takes the shape of its container. 3, they have a fixed volume because the amount of water that I'm going to be spilling on the table is the same amount of water that was in the cup. So the volume stays the same. It does not change. The third state of matter that we're going to talk about today is gas. Gas particles are more apart than liquid particles. They are the furthest from all of them. 2, they don't have a fixed shape or volume. Now, for example, if I have a balloon, this is like an exception, okay, and I put air in the balloon. Now, when I put the air in the balloon, it's going to keep on blowing and blowing and blowing and blowing until it gets to the maximum. Now, it's going to be filled with gas particles. It's going to be filled with gas particles. Now, these gas particles are going to keep on expanding until they hit the surface of the balloon. So they are going to be bouncing between each other. This bouncing movement and how the gas particles are touching the surface of the balloon, we call it pressure. All right. Now, the next thing we're going to talk about is the change of state. States are the 3 states of matter. So we're going to say how we change the states of matter. Let's start with solid. We have solid to liquid, and then we have liquid to solid. And then we have liquid to gas, and then we have gas, to liquid. Now, the change of state from solid to liquid, we call it melting. The change of state from liquid to solid is called freezing. And the change of state from liquid to gas, we call it evaporation, or we could also call it boiling. And the change of state from gas to liquid, we call it condensation. Now, these are the names of the 4 states of the 4 change of states that we are talking about. Now we're gonna talk about something else extra, which is the energy. We all know that every state of matter has a different kind of movement. Their particles move differently. In a solid, they vibrate. In a liquid, they're further apart, so they take the shape of the container. And in gas, it is the furthest, so they be flowing everywhere. What makes these particles all move? It is energy, because all particles have energy that is making them move. So, we're gonna talk about less and more energy. If I want to add heat in order to melt from a solid to a liquid, we need more energy, which means gaining energy. But if I'm going to change it from a liquid to a solid, which is freezing, I need less or losing energy. In a liquid, in order to evaporate something, you add heat. When you add heat, you need more energy. So we're going to be gaining energy when we evaporate. And when we change from gas to liquid, we are going to be removing energy, so it's going to be less energy. Okay. An example that I'm going to give you right now is ice. Ice cubes. Now, ice cubes are solid. We all know that. They are the solid state of matter. If I add energy, if energy is gained, we call it melting, which is going to change into liquid water. Sorry, boys, that was a cup. Anyways, so when we melted ice, it turned into water. And then when we add energy to water, it's going to turn into a gas that we call water vapor. Then we could change water vapor back to water, and we could change water back to ice. These are the change of states that we talked about, and now we're going to talk about something else. We have a phrase that is called reversible change. The word reversible comes from reverse, reversing things. For example, if I have a car and I want to go backwards, I reverse. That's what reverse means, going back. So, some changes are reversible. For example, like when we talked about ice over here, ice, we changed it into water, and then we could change the water back into ice. It is reversible. It could go back to what it was. The next phrase we're going to talk about is called physical change. We're going to talk more about physical and chemical change in the next lesson, but for now I'm going to give you a brief idea of what it is. Now, physical change is when the identity means the name or the substance itself, or the way it looks. The identity of the substance stays the same, which means no new substance is formed. Only the way it looks changes, but no new substance is formed. So if I have an apple, for example, and I cut the apple in half, I'm gonna have an apple, but cut in half. So the way it looks changed, but it is still an apple. That is a physical change. Now let's talk about chemical change. Chemical change is the exact opposite of physical change. And another word for chemical change is chemical reaction. They both mean the same thing. The definition is when two substances react. Understand the word react, يعني بتفاعلوا. They react together to form a new substance. Okay. An example. If I have a log is made out of wood, of course. So if I have wood and I want to put it on my fireplace to make a fire. So I'm going to add gas to it and start a fire. So when I burn the wood, we call this process burning, of course. We talked about it before. when I burn the wood, I have three things that were formed, or three new substances that were formed. Ashes or ash, CO2 gas, and smoke. Different kind of gases were formed. So they were two different substances. These are the two substances that reacted together to form these three new substances. So a new substance was formed, or new substances were formed from these two substances. Now let's go back to when we talked about reversible. Is this equation reversible? So when I burn wood, is it reversible? Can I take the ash and the CO2 gas and the smoke and turn it back into fire and wood like it was? The answer is no. They are non-reversible. That means they are not reversible. This is a non-reversible change. All right, everyone. Now, let's talk a little about a phrase or a word called pure substances. Pure substances, it means that all the particles are the same. We'll talk more in detail about this in the next lesson also, because we have two kinds of pure substances, which are compounds and elements, and we're going to be talking about compounds and elements when we talk about chemical reactions. But a brief example that I'm going to give you about this is gold. A gold necklace, for example. We all know that a gold necklace is made with gold. All of it is gold. There was no new substance added, and there was nothing that we mixed with gold for it to become a gold necklace. So it is all made of an element called gold. So it's little particles of gold that are combined together to form gold. So the particles are all the same in a gold necklace. So let's talk a little bit about mixtures. Now mixtures are, there are mixtures that particles of different substances are mixed together, but some of them are not joined together and some of them are joined together. The type of mixture that I'm going to talk about today is a solution. But before the solution, I want to give you an example about a regular mixture. If I want to make a salad, salad has vegetables in it, for example, tomatoes, cucumbers, lettuce, etc. If I cut the tomatoes and I cut the cucumbers and I cut the lettuce, I will have a bowl of salad. The shape of the tomato and the shape of the cucumber and the shape of the lettuce changed, and they are all mixed together in a bowl, but the tomato is still a tomato and the cucumber is still a cucumber and the lettuce is still a lettuce. So this is also a physical change, because the way they look changed, but they are still the same vegetables. The next mixture I'm going to talk about is a solution. A solution is mainly solids that dissolve in water or in solvents, let's say. Always a solvent is the liquid that allows the mixtures to happen. The liquid in the mixture, we call it a solvent. Now, simple examples about these to make it more easier for you. Now, dissolve means it melts into, so it all looks like one substance. For example, if I want to make tea, okay, I add the tea, which is the liquid, and then I add sugar, which is the solid. We all know that when we put sugar on our tea, the sugar will dissolve inside the tea. That is a solution. Another example could be water with salt. It could be sugar with your coffee. Any solids that dissolve in water. Now, any solid that dissolves in water is also called soluble. We describe it as soluble. So it is a solution, it is a soluble solution. Okay, I'm gonna introduce something new to you guys right now. It is a really simple process that we call diffusion. Sorry. Diffusion. Diffusion is mainly a substance or substances that spread out without stirring them. What does that mean? It means when I mix two substances together, they will react and give a reaction right away without me stirring it. They diffuse. The word diffuse is like coming out quickly, okay, right away. So one example, you guys could try this at home. You could add baking soda with vinegar. It will diffuse right away and bubbles will start coming out right away without stirring it and without using a spatula, without using a spoon, without using anything. It will spread out right away. That is diffusion. Very simple and easy. The last process that we're going to talk about today is filtration. Filtration is a process that separates the solids. It's a process that separates the solid from a liquid. Remember when we talked about soluble substances? We're going to talk about insoluble substances in filtration. I'm going to give you an example over here, which is mixing sand and sugar and water together. So here's my beaker. I add my water, and I add my sand, and I add my sugar. We all know that the sugar and the water will dissolve. But ask yourselves, does sand dissolve in water? The answer is no. Sand does not dissolve in water. So after you stir these three substances together in a beaker, you will see the sand particles will start flying around and the sugar particles melted, dissolved into the water. Now, if you let it stay for a little while, you will find that the water and the sugar are dissolved and the sand will be at the end or the bottom of the beaker. So this is step 1, and then this is step 2. And don't forget, we call water a solvent in this kind of experiment. Now, how do we separate the sand from the water and the sugar? In a process that we just described, which is called filtration, we need to filter it. So we get a funnel and we add it and we place it in a beaker or in a flask. And then we pour our mixture on the top. When you pour it on the top, the insoluble substance will stay in the top, in the funnel paper, and the soluble substances will go down. The insoluble substance in this equation is sand. Why? Because the sand did not dissolve in the water, while the sugar and the water, they did dissolve in each other, so they are soluble. So the insoluble substance, which is the sand, will be on the top here, and the water with the sugar will be down here. Now, we finished our filtration with the sand. Now we have our last step. Now we will have our flask right here. Sorry, don't mind my drawings. I'm not really good at drawing that much. We will have the sand, the water, and the sugar over here. The separating process that we are going to use now is evaporation or boiling. And in order to use evaporation or boiling, we are going to need fire for that to happen. We are going to need heat. So when we heat this solution right here, which is the sugar and the water will turn into a gas that we call water vapor. It will evaporate in the air. And in the bottom over here, we will have crystals of sugar or sugar crystals. All right, everyone, I hope you understood the lesson. I will have a worksheet ready for you guys for class to solve after you finish watching this video. Thank you.